The Clarion-Clipperton Zone, or CCZ, is a vast underwater plain. It lies in the Pacific Ocean, stretching between Hawaii and Mexico. Spanning an area of about 2.3 million square miles, the CCZ is larger than the continental United States. It sits under 2.5 miles of water, shrouded in perpetual darkness and subjected to immense pressure. Despite its harsh conditions, the CCZ is a hotbed of biodiversity. It is home to a plethora of marine life, much of which remains undiscovered. Yet the real treasure of the CCZ lies scattered across the seabed. These are not gold coins or pirate booty, but polymetallic nodules, potato-sized concretions rich in valuable minerals. These nodules, formed over millions of years, represent a potential source of immense wealth. They contain manganese, nickel, cobalt, and copper. These are key components in electronics, batteries, and green technologies. The CCZ has become a focal point for deep-sea mining ventures, hoping to tap into this mineral wealth. The future of the CCZ hangs in the balance. We face a critical decision. Will we exploit its resources to fuel our technological advancement? Or will we protect this unique ecosystem for future generations? The choices we make today will have far-reaching consequences. The CCZ is characterized by its unique geology. This region of the ocean floor is known as an abyssal plain. Abyssal plains are among the flattest places on Earth. The CCZ is no exception. It formed over millions of years as sediment slowly settled on the ocean floor. What makes the CCZ truly remarkable are the polymetallic nodules that litter its surface. These nodules are formed through a complex geological process. It starts with the slow accumulation of metals dissolved in seawater. These metals precipitate around a nucleus, often a fragment of rock, a shark tooth, or even a piece of bone. Over millennia, layer upon layer of metal hydroxides and other minerals accrete around this nucleus. This process, driven by chemical reactions and microbial activity, results in the formation of the nodules we see today. The nodules grow incredibly slowly, at a rate of just a few millimeters per million years. This makes them a non-renewable resource on a human timescale. The sheer abundance of these nodules in the CCZ, however, has sparked a debate. Are they a sustainable source of essential minerals, or should they be left undisturbed on the seafloor? Polymetallic nodules are not just geological curiosities. They contain high concentrations of valuable metals. These metals are essential for our modern world. Manganese, nickel, cobalt, and copper are all found in these nodules. Manganese is crucial for steel production. Nickel is used in batteries and stainless steel. Cobalt is a key component of lithium-ion batteries, which power our smartphones, laptops, and electric vehicles. Copper is essential for electrical wiring, plumbing, and a wide range of industrial applications. The demand for these metals is skyrocketing. This is driven by population growth and technological advancements. The rise of renewable energy technologies in particular has increased the demand for cobalt and nickel. This is because they are essential components of batteries used in electric vehicles and energy storage systems. The potential of polymetallic nodules to meet this growing demand is undeniable. The CCZ alone is estimated to hold trillions of dollars worth of these metals. Proponents of deep-sea mining argue that it offers a way to secure the resources we need for a sustainable future. However, the environmental impacts of extracting these minerals from the seabed remain a major concern. Governing the high seas, ISA and the regulations for deep-sea mining. The Clarion-Clipperton Zone lies beyond national jurisdiction. It's part of the high seas, considered the common heritage of humankind. The International Seabed Authority, or ISA, established under the United Nations Convention on the Law of the Sea, is tasked with governing mineral resources in this international seabed area. The ISA has granted exploration contracts to various countries and companies. This allows them to assess the resource potential of the CCZ. However, the ISA is yet to finalize a set of regulations for commercial deep-sea mining. These regulations, known as the Mining Code, will establish the environmental standards, financial terms, and other rules for deep-sea mining operations. The ISA is under pressure to finalize these regulations. Many countries and companies are eager to begin mining. However, there are growing calls for a precautionary approach. Environmental groups and scientists are urging the ISA to prioritize environmental protection. They argue that more research is needed to understand the potential impacts of deep-sea mining before it is allowed to proceed. To mine or not to mine, weighing the economic benefits against environmental risks. The prospect of deep-sea mining in the CCZ is a double-edged sword. On the one hand, it offers a potential solution to the growing demand for critical minerals. These minerals are essential for our transition to a green economy. They could power electric vehicles, renewable energy technologies, and countless other innovations. The economic benefits of deep-sea mining could be substantial. It could create new industries and jobs. It could also generate revenue for the ISA, which could be used to fund development projects in developing countries. However, these potential benefits come with significant environmental risks. Deep-sea mining would involve excavating large swaths of the seafloor. This would destroy habitats and ecosystems that are still poorly understood. The process of extracting nodules and transporting them to the surface could release plumes of sediment and potentially harmful chemicals. This could impact marine life over a wide area, including fish stocks and other marine organisms. The long-term ecological consequences of deep-sea mining are largely unknown. Some scientists warn that it could disrupt the ocean's ability to regulate climate change. It could also have unforeseen consequences for the deep-sea food web and the overall health of the ocean.